video in image formation, some rules for the image formation. In this video, I'm going to discuss about the ray diagram and the basic equation, the mirror equation, and how to find out if we know the position of the object where the image can be formed with the help of this ray diagram. So here you can see this is a concave mirror. Outer side is polished, inner side is reflecting, and this is the parallel axis, C center of curvature, and the focal length. And AB, this is object, and H is the height of the object. The first ray we actually, which is shown here, that we start from the point A all the way parallel to the parallel axis, and it's reflected, and after reflection it passes through the F, the focal point. Other ray starting from A, and it moves towards the pole of the mirror, and it's reflected from there. So in this case, the angle of incidence is equal to angle of reflection. Third ray, which all the way passes through the C here and retraces its path. If you see all these rays after reflection, especially this one and this one, passes through the same point, these points of intersection, the point of intersection, and the C is also passing through the same point of intersection. So this point of intersection where all these rays are intersecting, this is the point where the image is formed here. This is the image. And this is how we can find out where the image can be formed, if we know the exact values of the position of the object and the focal point. This one is the height of the object, and in case of an image, the height will also be like denoted by H with I, O. So this is simply, you can draw the ray diagram to find out the exact position of the image. The basic equation we use for which is called the mirror equation. D naught is distance of the object, Di is the distance of the object, and F is the focal point. So if we know these values, we can find out this one very easily. Here it's also mentioned that from the object to the mirror is D naught, and the image and the mirror is Di, and R is the radius of the curvature, which is always equal to 2F. Now if we move to the next slide, we can see the convex mirror ray diagram. This is a convex mirror, so its inner side is polished, outer side is reflecting. Okay, if the outer side is reflecting, the image formation will be a little bit different. Not a little bit, you can say it cannot form a real image. Here, this is your object. Okay, so focal point is here and C is here, is other side of the mirror, which is a polished side. So it is obvious that image is not going to form on the side where the object is. So image will be formed in the other side of the mirror. So first line is drawn here, which is exactly parallel to the parallel axis all the way to the reflecting surface, and it's reflected. If we extend this line, the reflected one, the other side of the mirror, like here, it passes through the point F. Similarly, another line from the point A, it moves all the way to the other side of the mirror and passes through the C. So this line and this line, they are intersecting at a certain point. Okay. Another line from the point A, which directly goes to the P pole of the mirror. Sorry. And then it's reflected here. So in this case, angle of incidence equal to angle of reflection. If we extend this reflected one to the other side of the mirror, it should also pass through the same point where the other two lines are intersecting. So this is basically the points where the image is formed. We can find out the location of the image like this. So image is forming on the other side of the mirror. So it means the image is not real. So image is not real. How we can find out this position of the image? Same equation we are using here. This is the distance of the object from the mirror, distance of the image from the mirror from the other side of the mirror. Okay, so if we know these values, like this one and this one F, we can find out the position of the image. We know the object, we know the F, we can find out this one. But one thing you have to keep in mind, the image is not real here, it's a virtual image. In case of previous slide, the object and the image is on the same side. Okay, so it means the image is real here, but it's inverted, exactly opposite to the object. Okay, so this is for a concave mirror. For a convex mirror, the object and the image, they are not on the same side of the mirror. So image is formed on the other side of the mirror, and this image is not real, it's virtual, but it's not inverted, it's upright. It's not inverted. Okay, but it's virtual. So there are some rules whenever we solve the problems related to the spherical mirrors that I will show you in my next slide. Okay. Here, as I mentioned in the previous slide also, this is the height of the object. The height of the image will also be h with the I, and this is all. We can find out the height of the image, or we can find out the ratio, which is called the magnification factor that I will show you in the next slide. Here, we have studied this equation. We learned about it a little bit. So this is object, image, focal point. So with the help of this equation, we can find out the image position. Other thing which I mentioned is magnification. So magnification M is equal to HI over H naught. It's a ratio, image and object height, and HI over H naught is equal to DI over D naught. So we can find out this ratio if we know the height. If we don't know the height, if we know these values, we can find out the ratio. Image distance and object distance. So if M is equal to 1, it doesn't matter plus or minus, when M is equal to 1, it means that the image and the object size, the size of the image and the object, same. If M greater than 1, it means the image is larger than the object. It's magnifying. If M is less than 1, it means the image is smaller than the object. It's not magnifying. Sign conventions. There are two possibilities what we have studied. Concave mirror, object, image. Convex mirror, object, image. Any distance measured on the object side is positive. This is object side. Any distance measured on the object side, that the image is formed on the object side, in this case, the distance is always positive. In this case, distance is negative because image is formed on the other side of the mirror, not on the object side. Okay, this is mentioned here. F, which is a focal length, is positive for the concave and negative for the convex. So F focal point, focal length, is positive for the concave mirror and negative for the convex mirror. Okay. Now, what it's saying here, the image distance is positive if image is on the same side of the mirror as object, as it's also mentioned before actually. In this case, the image, if the image is formed on the same side of the object, the image is real but inverted. The image distance is negative if the image is formed behind the mirror towards, behind mean to the side of the polished side, which is polished. So in this case, the image is virtual, but it's upright. It's not inverted. Okay. If M, this M is negative, then it means that image is inverted. If M is positive, then it means it's upright. Like in this case, the M will be positive, and in this case, M will be negative. Okay. In this case, which is concave, F is positive. Okay, in this case, F is negative. Okay, the distance of the image is positive, distance of the image is negative. So M is negative and M is positive. So these are some rules actually when you solve the problem related to the spherical mirrors. I hope you people enjoyed and tried to understand. In my next videos, I will explain or discuss about the lenses and their ray formation, ray diagram. Until then, I mean, let's say goodbye.